be teach, my dear students. Today our topic is under virtual management, the page replacement algorithm. So as the term indicates, it is algorithm. So we are going to make some sequence of instructions to control or to make the paging system in an efficient manner. So when the paging is becoming efficient means when the pages need to be swapped out and they need to be swapped in. That means swap out means the pages those are not required under execution, they need to be replaced. That means they need to be swapped out and they need to be loaded onto the disk, and another page has to be allocated in the memory. And here the number of free pages that are available in the memory are not sufficient to the number of pages that are going to be placed. Then to overcome all these things and to make the paging technique in an efficient manner, we are going to have the study of different algorithms that are given or used by the operating system. That means page replacement algorithms. So have a glance onto the subject. See this one. Page replacement algorithms are the techniques using which operating system decides which memory page need to be swapped out and write to the disk when the page memory needs to be allocated. Now here you can see paging happens if only the page fault occurs. When the page fault occurs, the particular page is not found in the memory, then they need to be fetched from the secondary memory. That means those number of pages need to be fetched from the secondary memory, and to fetch those required pages from the secondary memory, here we need the equal number of free pages in the main memory. If it is not equal, then how we can overcome? And we are going to study that through algorithms. When the page was selected from the replacement, was paged out and is referenced again. That means the swapped out page may be referenced again and it has to read from the disk, and this requires IO implementation. That means to swap out and to swap in the particular page from main memory to secondary memory and secondary memory to main memory, we need the implementation of IO operations. This process determines the quality of page replacement algorithm. That means how this is done. Maybe this is done with the help of the page replacement algorithm and the quality of page replacement algorithm. That means how efficiently this work is done by implementing particular algorithm is nothing but the quality of page replacement algorithm. Here the lesser time waiting for pages in and better algorithm is defined. That means to make the pages available for execution, not only swap out, the swapping in, that means making the availability of those pages required is done in a better way with the good quality of algorithm. A page replacement algorithm looks at the limited information about accessing the pages provided by the hardware and tries to select the pages should be replaced to minimize the total number of page misses. That means making the availability of those required pages in the main memory, reduce the page miss in the accessing time. Here you can see the reference string is used. The string of memory references is called the reference string. Reference strings are generated artificially by tracing a given system and recording the address of each memory reference. The letter choice produces large number of data where we have two things. One is for a given page size, we need to consider only the page number, not the entire address. The second thing is we have to reference a page P, then that means immediately the following references to the page P will be never cause page fault. Page P will be in the memory after the first reference, and immediately following references will not fault. And third one is, for example, consider the following sequence of addresses like 123.215.600, 123.476.96. If the page size is 100, then the reference strings are 1, 2, 6, 12, 0, 0. Now we are going to have the study of different page replacement algorithm. Among them, the first one is FIFO, that is first in first out algorithm. Here the oldest pages are considered, those need to be replaced. That means first in first out means the page first entered will be treated as old page. So the first entered page has to be replaced. That means first in, first out. So this old page has to be replaced to make the space free for entering new pages. Here you can see clearly the old page in the memory is one which will be selected for replacement. Now easy to implement and keep a list of replaces pages from the tail and add new pages at the head. That means already entered pages are referenced in the tail and new pages are placed on the head. This is called FIFO algorithm. So for that we are taking the stack organization to make the FIFO algorithm in a convenient manner. So reference strings are these, and in the reference strings these are the misses and these are the success. So how these things are happening and how we can overcome this fault rate, that means it has to be reduced with the help of FIFO algorithm. See, you can see the first one 0, 2, 1, 6. These are referenced and 4 has to be placed, that means 4 is missed. So 4 has to be placed onto the top of list, then 4 is replaced. Next 0 has to be placed after 4, that means 0 has been pushed. Next one is 3 has to be placed, 3 is placed. Now 1 has to be placed, 1 is placed. Now you can see the next one is 2 has to be entered, so 2 is entered in an order like this. So this is the reference string. According to the reference string, the pages are placed in the list. So next one is optimal page algorithm. In an optimal page replacement algorithm has the lowest page fault rate of all algorithms. In the optimal page replacement algorithm exists has been called OPT or minimum. The page here, the replacement page that will be not used for the longest period of time, and then what happens, you can see here, you can see the reference strings are given here and the misses are this 0, 2, 1, 6, 4 and 3. So what are the missed references? We need to replace them. Here you can see the 4 has to be replaced like this and 3 has to be replaced like this. So the optimal page algorithm follows like this. Next one is, now the next algorithm is least recently used. Pages which has been used very less time, that means not frequently, those pages has to be replaced with the help of page replacement algorithm. This is LRU. The next algorithm is page buffering algorithm. To get a process start quickly, keep a pool of free frames and on page fault select the page to be replaced. That means write a new page in the frame of free pool and mark the page table and restart the process. This is another algorithm to make the pages available for execution. Now write the dirty page out of the disk and place the frame holding replaced page in the free pool. Next one is LFU, least frequently used algorithm. The page with the smallest account and the one which will be selected for the replacement. That means very less used page that has to be replaced. This algorithm suffers from the situation in which page is used heavily during the initial phase of process but then never used again. That means maybe that page is used at the initial stage of execution but that page is not used in the rest of time. That page has to be replaced. Next one is MFU, that is most frequently used page. Here this algorithm is based on the argument that page with has the smallest count was probability just bought and had yet to be used. That means the main motto of this is most frequently used. That means most frequently used page has to be kept in the memory and least used one has to be replaced. Here you can see the difference between the paging versus segmentation. Up to now we studied about the page replacement algorithms. So which one is better one, paging or segmentation? We are going to have a glance here. The differences are like this. paging, non-contiguous memory allocation, and coming to the segmentation, it is also the non-contiguous allocation. Next one is paging divides the program into fixed sizes, while the segmentation divides the program into variable sizes. And for paging, operating system is responsible, and for segmentation, compiler is responsible. And paging is faster than segmentation, and segmentation is slower than paging. The fifth one is paging is closer to the operating system, while segmentation is closer to the user, and it suffers from the internal fragmentation. In paging, internal fragmentation is there, but it suffers from the external fragmentation. Now coming to the paging, there is no external fragmentation here, and there is no external fragmentation required in the segmentation. Now coming to the eighth difference, logical address is divided into page number and page offset, and here the logical address is divided into segment number and segment offset. While coming to the ninth difference, you can see page table is used to maintain the page information, and here also, like page table, we have the table which maintains the segment information. Here page table entry has the frame number and some flag bits to represent the details about page, while coming to the segment, it has the entry of base address of segment and some protection bits for the segments. So these are the differences between the paging and segments. So in the complete chapter, we studied about how the memory management is done, how the memory allocation is given to the processes in the multi-programming environment and single user multi-programming environment, multi-user multi-programming environment, and how the multi-programming, the degree of multi-programming is increased with the help of memory allocation. And in the time of memory allocation, few techniques we discussed, they are paging, segmentation and fragmentations, and among them the paging and segmentation are having equal importance. And coming to the paging technique, with the help of virtual memory, how the page replacements are done for making the available pages for execution in the main memory. We studied all of them with the help of page replacement algorithms. Thank you so much, students. We are going to continue in the next video with a new chapter.